Okay, for this video, we're going to talk about Z-scores, which are a measure of position. We're also going to talk about a 5-number summary and box plots, and a little bit about outliers. First of all, for Z-scores, these just give us the number of standard deviations that a given value is above or below the mean. If the value that we're interested in is below the mean, then the Z-score will be negative. If it's above the mean, the Z-score will be positive. Here are two formulas for Z-scores depending on whether we have sample data or population data. If we have sample data, then our sample mean is x bar and our sample standard deviation is s. Remember, our data value that we're interested in is always represented as x. So over here, under population, our mean is mu and our standard deviation is sigma. And we always want to round Z-scores to 2 decimal places. Here's an example. In this case, we have 2 different scores on 2 different tests, and we want to compare them. Since they come from 2 different tests, each one has a different mean and a different standard deviation, so it's hard to tell just by looking at them which one would be a better test score, relatively. So what we'll do is find the Z-score for each test. For our management test score, we're going to use 72 as x, since that's the data value we're interested in. Our mean is 80 and our standard deviation is 12, so here is putting those 3 numbers into our formula. If we calculate that and round it to 2 decimal places, we get 0.67. For our production employees test score, for this one we'll be using 19 for our x value. Our mean is 20 and our standard deviation is 5. So if we calculate that and round it, we get 0.20. So looking at these 2 Z-scores, the management test score would be relatively better. It's more standard deviations above the mean. In other words, it's just a greater Z-score. Now let's talk about the 5-number summary. This is just a way to summarize a data set. This consists of the minimum value, the first quartile, the median, the third quartile, and the maximum value. So it's just a list of those 5 numbers. And one of the things we do frequently with a 5-number summary is we use it to construct a box plot. A box plot has a box that includes the first quartile and the third quartile for the outlines of the box, and the median is represented in the middle somewhere with a line. Now the length of the whiskers, which are lines which extend on either side of the box, it depends a lot on the textbook or the software you are using. So I will show you what this textbook uses, and that is to first find the interquartile range, which remember is the difference between the third quartile and the first quartile. Multiply that by 1.5, and then the whiskers extend that far below the first quartile and that far above the third quartile. And if there are any data values that are beyond the whiskers, then they're considered outliers and they can be represented with special symbols such as an asterisk or a dot. So here's a box plot, and this is from an approximately normal distribution, so in other words a bell-shaped symmetrical distribution. And notice that our box in the middle has Q1 is the 61.5, the median here is 63.3, and Q3 is 64.95. And notice that since this is from an approximately normal distribution, that the median is nicely right about halfway between Q1 and Q3. And then our whiskers extend out to 56.33 on the lower side and 70.13 on the upper side. So both of those would have been found by calculating that interquartile range, multiplying it by 1.5, and then either subtracting it from the first quartile in this case, or adding it to the third quartile in this case. If we had any values that were either smaller than 56.33 or larger than 70.13, they would be represented out here by asterisks or stars or dots. Now here's a box plot that comes from a somewhat skewed distribution. This was supposed to be salaries in thousands of dollars of NCAA football coaches. So in this case, we've got our box in the middle Our Q1 was 205, so that would be 205,000. Our median was 300, and our Q3 was 638.44. So notice in this case that we don't have that nice symmetrical shape that we did for the other box plot. Our median and our Q1 are fairly close together, but the median and Q3 are fairly far apart. Now in this case, if we figure out how long our whiskers are, for the lower limit we actually end up with a negative value. If we find our interquartile range and multiply it by 1.5 and then subtract that from our first quartile 205, we actually get a negative 445.16. So for this one I just ended that at 0, since a negative salary wouldn't make any sense in this case. Our upper limit is 1288.6. And notice in this case we had an outlier out here that was 2840, so that's represented by an asterisk. Okay, now we keep talking about outliers. These are just values that lie very far away from the vast majority of the other values in a data set. And how they are defined depends on how you're looking at the data. Some of the most important ideas about outliers, though, are that they can have a dramatic effect on the mean. An outlier can also have a dramatic effect on the standard deviation. And if you're looking at a histogram or another type of graph, an outlier can have a dramatic effect on the scale of the histogram, so that you can't really see the true nature of the distribution. Now, if we're looking at outliers using z-scores, we can define an outlier either by using z-scores or by its position in a box plot, which we already saw. And again, in this textbook, they define these a little bit differently than in some other textbooks. In this textbook, if you're looking at an outlier depending on z-scores, to be an outlier, the value must be more than 3 standard deviations away from the mean. So that means if you're looking at the actual z-scores, the z-score would have to be less than -3 or greater than 3 for the value to be considered an outlier. Now, outliers for box plots, as we already discussed, we consider a data value an outlier if it is above that upper limit, which would be more than 1.5 IQRs above Q3, or if it's below the lower limit, which is more than 1.5 interquartile ranges below the first quartile. So here's another example of a box plot. And notice in this case we've got our box, so we know we've got Q1, the median, and Q3. And here are our whiskers, which give us our lower limit and upper limit. We've got 2 outliers that are beyond those limits.